Here is another example involving the graphing of the least squares line of best fit. So what we're going to do first of all is calculate the correlation coefficient R. We're also going to calculate the least squares, the equation of the least squares regression line too. I was just going to use the calculator to do that. Now, have a look at the values in the table there, and I've graphed them here just for your convenience. So we can see that there appears to be a positive correlation there, and seems quite strong as well. So you can see that a line seems to a line of best fit there. The points seem to be would be fairly close to that, but we're not going to do a line of best fit by eye. Okay, so what we're going to do, let's use the regression mode again. Okay, so just going to zoom in here on the calculator just so you can see what I'm doing. Okay, if you remember, mode, stat, and number 2, a plus bx. So remember, the a refers to the y-intercept, the b refers to the gradient. That's just what the calculator calls them. Okay, we ourselves don't call it that. They're not the correct pronumerals as to how we're taught. But anyways, we just need to just understand that that's how it works. Okay, so I'm just going to enter in the values. So hopefully we can see that. Yep. So I'm going to enter in the row 1, 2, 3, 4, 5, 6. Then I'm going to enter in the next row. Okay, so 1.3, 1.9, 2.5, 4.0, 5.0, and 6.5. Okay. So next, remember, shift 1, hopefully. All right. And there's our friend Reg. Okay, number 5. Now let's calculate the correlation coefficient. So let's just confirm our suspicion that it's a strong positive. And we get 0.986. Okay, so I might just write that here. R is equal to 0.986, which indicates a strong positive correlation. Okay, so that's a strong positive there. Right, now let's calculate, or let's find the line of best fit, or the least squares line of best fit. Okay, so the data's still in there. Shift 1. Okay, Reg. Now remember, A is the y-intercept. Okay, so the least squares, I'll zoom out shortly. I'm just going to write this. So the least squares line of best fit. So I'm just writing this down on the board. Okay, so is y is equal to okay, so I'll probably find the gradient first, just so I can write it into y equals mx plus c form. So we'll find the b first. So that's going to be the gradient. Okay, so that's going to be 1.05 x. Okay, and let's go back to Reg again. Number 1a minus 0.15. Okay, so that is our least squares regression line, or the equation of our least squares regression line, or our line of best fit. Okay, now plotting that, what would that look like? So I'm just going to put the other board here. So that's this board. I'm just going to zoom out and let's plot this equation. So I might just write this here. So the least squares, right, line of best fit, right, is given by y is equal to 1.05x minus 0.15. Okay, what I'm going to do now is I'm going to pause the video. I'm going to sketch it on there, then I'm going to unpause the video, and then I'll quickly explain how this works. But just before I do that, why don't we plot a few points on our table? Okay, so that's why I actually had another row there. So our least squares line may not necessarily correspond to the actual y values. Okay, so let's just work out what our least squares line is going to look like, at least in a table, and then we're going to convert that into a graph. So let's substitute in these values. Okay, so hopefully you can see that. Let me just brighten that a little bit. All right, 1.05 times 1 minus 0.15. Okay, and we get 0.9. Okay, so all I'm going to do now is I'm just going to change that to the x value to 2, which is 1.95. Okay, I probably should round that to one decimal place, but I'll just leave it like that for now. So that's in fact 2.0. Okay, that's 3. So there's an x and a y value. The least squares y value is identical there. Okay, 4 is 4.05. Okay, 5 is 5.1. And 6 is 6.15. Okay, so we have those points. All right. We also have the y-intercept here, which is negative 0.15, and that's what we'll need to put on the graph if you can. Otherwise, we've got a few points here in red, so we can use the x values and the points in red to then graph our least squares line of best fit. All right, so let's do that. All right, so just going to move this board out of the way. In fact, I might just put this here. All right, and I just want to see if we can somehow get this table there. All right, and what we could do is we could just pick two convenient points. Okay, so we could pick this point here, maybe the 3, 3, 3. I think that would work. I'd pick 3 points. So maybe this point here. Okay, so 3, 3. So where would that be? So if you have grid paper, obviously, or a grid book, this would be very, very easy. Okay, I've drawn this to scale, so it shouldn't be too difficult here. So 3, 3. I'll do this in a different color. That would be roughly here. Okay, so the least squares line would go where the red X is. Okay, let's have a look and see if we can identify another value. All right, and maybe 6. Try and pick points that are quite far apart from each other. 6, okay, and we got corresponds to 6.15. Okay, so okay, 6. Okay, so that's 6.15, so it's probably going to be somewhere here. Okay, where it's got, that's 12, that's 6, so 6.15 should be 12.3, so it's probably somewhere around there actually. Okay, somewhere there. All right, and might choose one more. So maybe this one here. Okay, so 1 and 0.9. All right. So when x is 1, okay, y is 0.9. So 0.9 corresponds to 1.8 centimeters on my ruler. So it's around there. All right. Okay. So you've got to do this to scale. Okay, it's very, very important. All right. So there's our least squares regression line, or at least the points that's going to make up the least squares regression line. Let's join up the dots, the red dots. Okay. If you've done this properly, the dots should line up. Now I've probably done this slightly off. Okay. So I think it's okay. I'm rubbing off some of the ink, but obviously if you're using pen, it's probably a little bit easier. All right. Maybe a bit blow it down. Yep. And it's about there. All right. There you go. Okay. And that's our least squares regression line. Y is equal to 1.05x minus 0.15. The y-intercept is in fact negative, and it should go slightly under the x-axis there. So that makes sense. And you can see that we're probably lucky here that the least squares regression line does in fact pass through, or looks like it passes through 3 of the points, but there's 3 of the other points that are slightly above, in fact. Okay, so that can happen. That's a possibility that it could happen, that the line of best fit doesn't quite follow the rules that we've learnt when we're doing that by eye, but that is in fact correct there. Now, going back to this table, this is one last point. Sorry, I know the video's gone on for a bit, but you can see here that the actual data points and the least squares data points aren't necessarily the same. Okay, so don't expect when you're checking to see if you got your least squares line of best fit correct, okay, that when you substitute in the values of x into the formula, don't expect to get these values here in black, these y values in black necessarily. Okay, as long as you can see the trend, that's what you need to be looking for. I think we can see here that we're pretty much on the mark, and when you graph it, you can see that it makes sense, and it is in fact the line of best fit.